Vice President and Head of Engineering for Tata Projects Limited. Welcome.
Good morning all. Myself Somnath Nandan from Tata Projects India. So I look after the engineering and design of heavy civil infrastructure department. So today I will present few case studies. I'm not giving any intro to the organization because it is already there in your conference app in my brief. So here I will cover the case study, how we apply the technologies in different projects, like underground metros, airport, and how we use the construction methods and erection in few of the projects like elevated metro, housing project, and a ceiling bridge. Then I will cover design and drafting tools, what we are currently using, and then challenges what we are facing and new area what we are exploring. So this is underground metro in Mumbai. It's a 33-kilometer underground metro where we are actually constructing one of the packages, which is about 6 kilometer twin tube bored tunnel with 3 underground station. Now you know the underground station is very complex. Here in a box which is sitting under the ground, you are packing so many things like mechanical, electrical, plumbing, firefighting, a lot of architectural requirement, fire safety. So it is very important to have a model which ensures that it fits together. So we are taking example of one station. It is Dadar station. So you can see how we model the station here. So this is the bottommost level, which is called undercroft, and gradually you come up on the top with different services. So this is the platform level, and you can see on the both sides you are housing the plant rooms, tunnel ventilation system. So you are coming up gradually, and then you are coming to the concourse level where the ticketing and other facilities are done, and also is housing all the electromechanical rooms on either ends. So this is the top of the box, and you come up to the street level. So it is a very tight, congested area. So we have a model ready which will allow us to plan how we work there, how we make the traffic diversion. So here there are different components of the project. Like you can see a cross section is there are so many components we have there: escalator, lift, cable tray, concourse area, access fare office, AFC gates. So all these components are planned in advance so that there is no clash and the employer's requirements are met. So the contract requirement is that you need to take a printout in a paper, and which you need to get signed by client before it goes for construction. So you use the model to take out the prints at different levels, sections and elevation, and then it gets approval from the client and it goes to the site for construction. So we do the class check here between the electromechanical and architecture, different class checks. Second example is another underground metro in Lucknow. So it is 1.86 kilometer of twin tube bored tunnel with 3 underground stations. This project status is completed. The previous one, it is ongoing. So these we handed over in 28 months to the client, train running now. So this is a precast segment yard we modeled in advance. So it is having the molds where we pour the concrete for the precast tunnel segment. Then we have the curing, steam curing, and we have the long line for storing and then lifting it up and taking it to the project site. And so we have the batching plant, we have the reinforcement binding area, we have the stores. All these things are planned in advance. So the logistics can be done with the shape of the land we get. So there are some real pictures here. You can see the batching plant top right. Below the stockpiles of aggregates, bottom left is the segments stored. So these are a 5+1 segment. So 5 segments and 1 key segment. So these are visualized before execution. So this is the tunnel boring machine launching shaft. So So we modeled it earlier to see all the requirements. So you have the gantry, you have the cranes to put the machine down and then drill through. Now we are monitoring one or two of the stations with this color-coded model. So we have actual and we have the planned, and we can see how the progress is going on. So we are using a software called Navisworks to model the tunnel shape, because it has a horizontal profile, it has a vertical profile, it has the rings. So different kind of rings are there. So that is the tunnel boring machine launched in the shaft, and that's the finished tunnel of this project. We use BIM 360 so that in a smartphone, the project people at the site, they can see the model. This is another Allahabad Airport project. Here the scope is terminal building, landside, and apron and taxiway. So this project is completed, designed and built in 11 months' time. So we have developed the architecture and structure model for visualization and coordination. Because of the time shortage, we could not model everything. It is about LOD 200 level model. So we use the path analysis for the aircraft movement, because there are sharp turning radius. From the apron, it goes back, reverse, then it takes right turn. It takes the taxiway and go to the main runway. So different views. So here we check that the right of way and the envelope is maintained. So there is a huge car park, and this is a very, monsoon season is very heavy. So we use the software to calculate the drainage requirement and put the drainage system, the stormwater drain. So there is a video, I think I need to get out from here. So I'll explain a few case study on the construction engineering side, which is very important for us as a contractor. So this is elevated metro project in Delhi, which is 9.6 kilometer elevated viaduct with 6 stations. So this project is completed. So here the formwork, because a large pier cap to support the viaduct, and this has got very complicated dimensions, so we have to model it properly to support system. So you can see the support system is modeled, and bottom right is the actual picture at the site. So this is the very important for us as a contractor. So we have very complicated reinforcement detail in the pier cap supporting the viaduct. So you can see reinforcement coming in all directions, longitudinal, transverse, vertical. You have the stirrups, and also you have the cables for the post tensioning. So we do class checks for this reinforcement, also take out the bar bending schedule from this model. So different views. So this is a housing project in Mumbai where we create the site logistic planning through the BIM model. So you have the tower cranes, you have the, because it's a very tight construction site, so working area is very limited. So we had to model this to see how the transit mixtures and other construction vehicle will move around in the facility. So this is a basement. So we do a concrete pour planning model where we use it for the logistics. So this is a project monitoring which is used for tracking the project in terms of progress. It gives the basic concrete quantities and also some color coding of actual versus planned. So this is typical quantification from the model. So we use this for concrete quantification, also for the material finishes in architecture. So it's a 4D construction sequencing. So we have a model that we connected to the Primavera program, and with the cost. Now this cost is a basic cost of concrete, and we see the right. I think this video will not work probably. No, so it's not there. So this actually gives how the project is coming up, in terms of the progress percentage, in terms of the location, in terms of the pour, along the timeline of the project. So this is the Mumbai Trans-Harbour Link project, and this is a 22 kilometer sea link currently under construction. So there are 3 packages. We at Tata Projects, along with the Devu, we are doing the second package, middle of the sea, which is about 7.8 kilometer long 6-lane bridge, and in between we have a 1.73 kilometer of steel deck, which is steel superstructure. The project value is 806 million USD. It's a 54-month project. We are about 10 months on the way. So package to more detail. So we have 3 sections: marine section, which is a deep sea, then you have intertidal section, and then you have the land part where you have an interchange. This is a typical cross section of the bridge. So you have 2 independent structures carrying 3 lanes up, 3 lanes down, and bottom is the visual of the project, of the structure. So it basically having a 4 pile to 6 pile group, a pile cap which is above the water, then you have pier cap, and is a precast segmental box cutter, about 60 meter span. This is the architectural view of the bridge. So here in terms of the construction, I will show you 2 examples. One is this pile jacketing. So this is the piling of the main piles in the marine section, which is about 2 meter diameter pile, and you have the water about 8 to 10 meter. Then you have the marine clay, and then you hit the rock. So the sequence is that you bring the pile jacket, which is basically the steel frame on a barge, and then through the crane you put 4 piles, pin piles, and it goes up to the ground. Then you use the vibro hammer to put it in the right location, and then the barge moves out, and then you bring the permanent liner. Then you use the liner till the level where it is required to have a sufficient embedment in the rock. And then you bring the rotary core drilling machine. These are 2-meter diameter pile, and it has embedment of in the rock, hard rock, about 12 to 13 meter. And the pile reinforcement cage is lowered. And finally, the concrete is poured, and this process is repeated. Now, the idea of doing a model is that we have a full model of this, in a real, in actual dimension, and then we see how it fits together in terms of the, safety, risk, accessibility, and then we have a mock-up based on this model at the site, and then we do it. So currently the construction is going on. So you can see the bottom right, that's a marine batching plant. Left, there is a crane barge, and in front there are 2 pile cap. One is the right one is the pile is completed. Left one, the piling work is ongoing. And in behind you can see 2 more pile caps which are under construction. So few more views. There's a pile jacket. You can see the crane barge. You can see the rotary core drilling machine. This is another thing where we have a precast segments of the superstructure. So you understand it's about 8 kilometers out of that 6 kilometer twin deck. You have so many huge segments. So we bring the segment from the casting yard and put it on a jetty, and then then with a gantry we put it on the barge. So we consider all the high tide, low tide situation, the wind situation, and we modeled it properly. So see the tolerance in terms of all the things should fit together. So here we are lifting the segment from the truck, then we are placing it on the barge, and then the barge moves out to the location where it will be erected. Oh, there is another video probably. So the idea of the model is that whole construction method is developed and is shown to all the stakeholders for their consent. This is a temporary jetty for construction of the foundation in the intertidal zone, where barge is not possible because there is no sufficient water depth. So this is RCD drilling the piles. is our precast here, where we manufacture the segments. This is a launching gantry which will take the segments and then stress it. So these are the steel parts where we are procuring steel from 4 countries. And the steel girders are assembled at the site, and we are taking it on a large barge. These are the flamingos there. It is a naturally sensitive habitat. So we follow certain rules required by the environmental regulations. So now back to the presentation. So design and drafting tools, we are currently using the softwares here for structural analysis and design. Then geotechnical drafting, we are using the Autodesk Root. We are using the Bluebeam, Autodesk Beam 360. For documentation, we are using Aconics ProjectWise. CAD's RC for rebar, on-screen takeoff for quantification, and for alignment we are using Bentley. So challenges. So in India, all the projects are currently coming in design and build, and so 10 years back, a typical metro project, elevated metro, which used to take 4 years, 48 months, now they have squeezed to 28 months. And that's 100% design and build. So it is very difficult for the organization as a contractor, to prepare a full-scale model and hand it over to the construction team. So the day we get notice to proceed from the client wants a groundbreaking ceremony, and and our project manager wants a construction drawing in hand. So that's the situation. So what we are doing actually, all the complicated areas like the station, like the tunnel, some complicated part, we are modeling. So the whole project, it is very difficult to model in that short period. But in some projects where there is a design phase of about 6 months, there actually we are doing the BIM. Then the availability of the skilled workforce. So actually the whole chain, so engineering and design team, which I am looking after, they are compliant to they know the stuff. But when we talk to the project, so there is a construction manager, there is a section in charge, then they have the supervisor, then you have the scheduler, then you have the planner. So they do not want to go with a different route. They follow the standard drawings, they follow the spreadsheets, Excels, and they are comfortable with that. And there is no time required where the contractor can afford, currently to train them. So we have started the process so that we can train the people so that they can adopt this technology. Obviously, it will benefit everyone. Fourth point is the consulting engineers. They are yet to adopt 3D modeling. So I'm talking Indian context. So the whole chain from the draftsman to the engineer, then it is coming to us. They are partially adopting. So sometimes there is a case that where we get a drawing, then we have to take a printout and check. So which is actually going against the fundamental of BIM. So we have different kinds of software. I think it's a nascent stage where we are learning. So interoperability, then cost of maintenance, Now software, they are now coming with the AMC cost, which is quite huge. Another thing is that we have the remote sites where it is heavy file size, require high-end machines and massive storage. So uploading, downloading, lot of software, they work on a network version. They don't work there. So we need a standalone version. Sometimes these are a problem for us or challenges. So new areas we are looking into. So currently it is very complicated to model the full project reinforcement detail into the concrete. So we are trying to do that so that the bar bending schedule can come from the model. Then adoption of the lean construction with automation. So we are planning to do some work there. Then we want to use the 3D printing tools for some of the areas like some building sector, some creation of some molds or some shuttering or form work through 3D printing. And next one is the virtual reality. We want to utilize this properly. So that's our target for next 2 to 3 years timeline. And that's the end of my presentation. Thank you for your patience.
Thank you, Somnath, for the great presentation of the advantages of modeling for infrastructure and additionally looking at construction sequencing and advantages that are there. We have some time for some questions. Does anyone from the audience have questions? Maybe I'll start with one and then they'll think about their questions. So what have you seen as the benefits in going through this construction sequencing process in terms of bringing together all of the different parties that have to be connected all the way from your logistics of your steel supply through sequencing, through equipment suppliers? What benefits have you seen in terms of the project performance?
Yeah, I think that the benefit is, so contractor, the benefit, there are two benefits, time and cost. So I think that using this technology, site logistics, it helps in time, and time is a cost, is a money for us. And also, if you see, most of the time we get the site established in a very strange shape of land, very tight with very reduced access. So the advanced planning is very important.
We have time for 2 questions. Yeah.
Thanks for the presentation. What's the main challenge when considering the different formats that you can have when having this kind of coordinate model?
Sorry, I'm not...
What would be the main challenge of the data formats of the model that you have in place? Or they are using all the same format?
Yeah, I think the main challenge is that you have different disciplines, So the inputs are not coming in time, because when you talk about the electromechanical, there are certain vendors who are supplying, say, lifts, escalators, and they are not, I would say, appointed at the date when we have started the modeling. So that information come late. So I think that's a big challenge for us. So it's a sort of disruption when you get some information where our model is almost 90% ready.
One more final question.
Okay. Some projects in Norway and the UK have gone completely paperless. How long do you think it'll be before these big infrastructure projects are paperless?
I doubt. So see, I'm from represent engineering department, so we are okay to have a paperless system of making the drawings. But when you see the employer, who are our boss, sorry, it's the name of the boss, So, they require, the contract requirement is you need to have a printed paper drawing final and the as-built drawing as final, and which has to be signed by all parties. So that's one area. Secondly, down the line, the construction team, they are not very pro in adopting these things, because it takes some sort of disruption in their normal schedule, and the projects are on a very tight time frame. So recently we had one project we are starting now, that is a elevated metro in a PPP model. It's a very large project. It's 23-kilometer elevated metro near Mumbai, 23 stations, where we have a joint venture with Siemens from Germany. Now, we want to use the complete VDC and sort of digital twin model before we start on the project. So what we find that from the Siemens experience in Middle East, their requirement was very stringent, and they wanted to have all kinds of formal process in place. But the project did not get a success in terms of the digital representation or the modeling as a whole. So finally, they gone back with a sort of 50-50 concept. Some part is model, something has been done in a traditional way. So they recommended to us that, whether you want to run the train or you want to have a model. So that's the question they asked us. So we are going some in-between approach where we have to stick to the timeline, because time is very important for us. Also the cost. Because client will not listen that, we exceed the time because we are preparing some kind of very nice model, which will be helpful, but in terms of the timeline, it is not meeting the client's expectation.
So with that, Somnath, thank you very much for the great presentation. Let's
Thank you
give him
very much.
another
Thank you
round
all.
of applause. And I'll ask you not to go too far, because now we are going to go to our panel.